Hello everyone, I'm Fuge Zhou, Head of Data Science at RapidCanvas. At RapidCanvas, we help enterprises take their AI initiatives from concept to production and run them at scale. We do that with a combination of human expert and our own agent AI platform. Today, I want to walk you through a supply chain forecasting solution we built for our customer, a B2B manufacturer with long product lead times. We will go from their raw transactional data all the way to a working dashboard their planners use every day. Here is the challenge our customer was facing. Their planners were spending days every week manually pulling data from 3 separate systems: transactional bookings, open orders, and their legacy planning forecast, just to produce one monthly number. That's a lot of manual work before any real analysis even begins. The bigger issue was forecasting accuracy on their top SKUs, the ones that drive the most of the inventory cost, wasn't reliable. So safety stock decisions were being made on judgment rather than on data. And the shape of the problem is genuinely difficult. Over 300 SKUs, most with intermittent ordering patterns, plus a 3 to 6 months lag between when a customer places an order and when the product ships. They didn't need another spreadsheet. They need a proper AI-assisted planning system that handles their end-to-end solutions. So here is what we built for them on RapidCanvas. 3 components working together. First, SKU segmentations. The system automatically picked the right model for each SKU. Second, a 2-layer forecasting engine. We predict the bookings first, then derive shipments from the bookings. And third, an executive dashboard that replaces the manual spreadsheets. All of this runs on our enterprise context engine. What that means is the system learns continuously from the customer's unified data, and it adapts to their planning workflow, not the other way around. Let me show you the app. This is what a planner sees when they open the app in the morning. At the top, the headline numbers is 328 SKUs by planned combinations, 84,000 units of bookings over the last 3 years. And this one, aggregate forecast bias of 1.0. On our A-class SKUs, our predicted total matches actual total. That is about as good as it gets. Below that, every SKU is assigned to 1 to 3 tiers. 40 A-class SKUs carry the majority of the volume. And then we have a middle tier and a long tail. Each tier maps to exactly one model. So the logic is transparent, and the planner can always see why a forecast looks the way it does. One more thing worth mentioning. The Amber callout at the bottom lists what the release and what's on the roadmap. Enterprise customer tends to trust you more when you are upfront about the gaps. So we always surface that on the first page. The second tab is SKU segmentation. The textbook approach here is ABC by XYZ, a 9-cell grid. We look at the data and deliberately collapse that into 3 simple tiers. So every tier maps to a single model. Tier 1 is top volume SKU with at least 2 years of history. Those go through a machine learning model. Tier 2 is enough history and volume, but not A-class. These use a time series model, blending seasonality and recent momentum. Tier 3 is the long tail. Sparse intermittent demand will use a 12-month average or flag them as a make-to-order candidates. Look at the donut chart on the right. It's a classic pattern. 20% of the SKU carries 71% of the volume. That's where the machine learning investment goes. Now, this is the core page, demand forecasting, where the real value sits. One design choice worth calling out upfront: we forecast on booked date or order date, not shipment date. Why does that matter? Because a customer booking is the truth, unconstrained demand signal. Shipments happen after capacity and material constraint kicked in, so they are on a downstream constraint view. Bookings are the real demand. Now look at these 3 scenario cards, where rather than giving the planner a single point number, we give them 3 defensible scenarios. The low case is the conservative case, where it's based on pure statistical model, no narrative overlay. This is the right number for worst case safety stock sizing. The medium number is our recommended planning number. It assumes demand stabilized around the recent 12 months baseline. The high number is the optimistic case, assuming external tailwinds like upstream capex cycle or pipeline conversion materialized. And here's the important part. We also overlay the client's own legacy forecast in red. Notice that their forecast sits above our high case. Our position isn't that we are trying to beat their plan. What we are delivering is a defensible middle ground with 2 honest bounds on either side. The business then decides which scenario to plan against, and that they know exactly why. Here comes the accuracy and backtesting, where we gain trust from the customer. A lot of vendors will show you a compelling forecast. The real question is, how do you know the model actually works? That's what this page is for. We run a rolling original backtest. Every month we step back in time, retrain the model using only what is known at that point, forecasting next 6 months and compare to what actually happened. The model never sees the future it's predicting. Look at the first chart. It's A-class SKU. The aggregate bias is 1.100. Across all the volume that matters, our prediction matches actually almost exactly. This isn't a demo trick. It comes from a rigorous rolling backtest. Scroll down, you will see this scatter plot. Each dot is 1 SKUs, and most A-class dots sit between 0.7 and 1.3. There's a noise on individual SKU, but that's the nature of the intermediate demand. But the aggregate, which is what drives the inventory dollars, is unbiased, which means they sit around 1.0. So what does the planner actually get? They get 1 place instead of 3 spreadsheets. They get 3 defensible scenarios instead of a single point number. They can drill into each of any SKU, any plant, any horizons, and understand exactly why the forecast looks and the way it does. And because this runs on RapidCanvas, the system keeps learning as new data arrives. It's not statistics, it's not static, and it gets smarter every week.